share my screen here in just a second. We'll get confirmation from someone in the audience that we can see. Okay. Oh, there we go. That looks like a slide deck, right? Hopefully everyone's able to see the Hashicorp logo there.
It's coming up, I think. Should we?
Okay, looks good. Perfect. So we wanted to get started here with some quick introductions. My name is Josh Addington. I'm part of the solution engineering team here at Hashicorp. I'm based in Dallas, Texas, and I've been at Hashi for about 2 years now. It's been a wild and crazy ride throughout that time. I want to give Nico a minute to introduce himself as well.
Yep. Hey, I'm Kubar. I'm solution engineer. I recently joined Hashi about 5-6 months ago, but with been around the Docker and Kubernetes communities for quite some time, maybe 4 or 5 years now. So I'm excited to be present today about all things Hashi on the Kubernetes and CNCF ecosystem.
Awesome. Thank you, Nico. So we've split up today's presentation. I'm going to be tackling the first part of the agenda here today, doing a quick introduction on who and what is Hashicorp, and talk a little bit about what we call the cloud operating model. And then I'll also be going through the Hashi stack. So that's a quick look at all 8 of the projects that we maintain ourselves. And then I'll follow that up with talking a little bit about one of those tools in particular, which is Terraform, in a Kubernetes context. From there, that's going to get handed off over to Nico, who's going to talk a bit about using Hashicorp Vault with Kubernetes, a little bit about Consul as well, and he's got a demo that's going to follow in his segment. And then, of course, as Mars mentioned, towards the end of the session, we've got time set aside for Q&A. Also, whoever is not presenting, so myself or Nico, depending on the section, we'll be trying to monitor the chat there and tackle any questions that might come in from folks as we go. So hopefully that sounds good and sounds like what everybody signed up for here today. Mars, that sound right?
Yes, it's perfect.
Right.
Thank you very much.
Perfect. So I'll start with just that overview of Hashicorp, who we are and what we do. Typically, when we talk with companies, we tend to ask questions like this. Hey, are you having challenges moving to public cloud? Are you having issues replatforming your applications? Are you looking at modernizing your current infrastructure? Any combination of public or private cloud providers in there is typically where we hone in on. Why? Because that's what Hashicorp tools are designed to help the largest companies in the world do. And one of the great things about our solutions is that they really span that entire space, from small companies, individual teams working on a project, all the way up to the largest of the large in the space. So on this slide right here, it talks a little bit about that. You may be familiar with some of our software projects. You can see them listed on the right-hand side. I'm going to go into detail about each one of those here in just a few minutes. But the core idea here is that our tools are designed to help companies enable provisioning, securing, connecting, and running of applications and the infrastructure underneath them in any environment, in any cloud, public or private. Some history about Hashicorp. Our company was founded back in 2012. We're at actually well over 1,200 employees right now. I should probably update this slide. And over the almost 10 years that we've been around, we're sitting at about $350 million of funding. And one of the reasons that we've been able to acquire that funding and continue to grow our company is because we tell a story that we call the cloud operating model. And it starts a little something like this. In the past, we had this notion of a traditional data center where things were fairly static. And we typically stood up an application and it was installed on dedicated infrastructure, a physical server down in the data center or in the basement somewhere. But in today's world, it can look markedly different from that. The modern data center is very dynamic. And what we see from many of the companies we interact with is they have a mix of private cloud and public cloud. And they might kind of systems of record internally in-house, and then they typically push out their systems of engagement or the core tech that their customers are actually interacting with out into the public cloud. And when we look at this model, it's very, very different the way that you have to approach some core competencies within IT. We like to divide it out into 4 different layers. the run layer where application development happens, the connect layer where networking is happening, the secure layer where, you guessed it, security is happening, and then finally provisioning, where our operations teams are actually standing up the infrastructure that runs all of this stuff. In the old kind of dedicated infrastructure world, we pretty much figured that out over the past few decades. But trying to take some of those same patterns and lift and shift them into a public cloud world that's very dynamic presents a lot of challenges. And if we click in one layer deeper, we can see here how there's so many, I wouldn't necessarily say proprietary tools, but there's so many different tools, areas of focus, so many different languages and processes. One could lead a nice long career in IT being an expert in any one of these tools or solutions. And what we find many of the companies we talk to now are being forced to do is become experts across many of them, and in some cases, across all of them. That presents a significant challenge. And that's one of the challenges that Hashicorp is here to try to help people solve. The way that we do that is by taking our core solutions and layering them across that stack, from the private data center world with, say, VMware running in your own data center, over to the public cloud world, the big three cloud providers, AWS, Azure, GCP, and many others, where our solutions can help provide a singular workflow across those disparate systems. So now I'll take a few minutes and dive a bit deeper into each one of those 8, just to make sure everyone is familiar with all of these tools. Some of them are very new, introduced publicly as recently as 6 months ago. Some of them are a bit older, and some of them are a bit more popular, such as Terraform, which typically is known by many of the folks that we go out there and talk with. It certainly carries a bit more of a reputation, I think, than even the Hashicorp name does. So if you're familiar with Terraform, you are in fact familiar with Hashicorp. Terraform is all about infrastructure automation. It's a provisioning tool based on the concept of infrastructure as code. I'm going to dive a bit deeper into Terraform here in a few minutes when we get into the Kubernetes specific portion of today's presentation, but I wanted to share a couple of the use cases that Terraform is built to address. And it really hones in on that multi-cloud provisioning, multi-cloud compliance, and multi-cloud management of resources, where you can deploy a singular workflow interacting with a singular tool across all of those very, very different services. One thing that's unique about that approach with Terraform and with infrastructure as code is that we can try to abstract away a lot of the complexity of these different systems while preserving the uniqueness of the features and the services that are available in each one of those providers. Another key theme that we see out there that Terraform aligns nicely with is the concept of self-service infrastructure. Many of the companies we talk to, they want to be able to stand up a catalog, a storefront of some kind, so that you can have different personas across the organization requesting resources to be provisioned for them. And Terraform is nicely situated to sit underneath that request layer and actually perform the provisioning and configuration of some of those resources. Again, we'll spend a few more minutes on Terraform here shortly. Next up is Vagrant, and Vagrant's kind of tagline is development environments made easy. I like to talk about Vagrant as a tiny Terraform in a sense, because what it's designed to do is help you define exactly what you want to build a development box like, configure the operating system, configure users on it, configure settings on it, and be able to deploy those quickly and easily. It's great for passing out to development teams so that they're all building from the same unique starting point. It's great for passing out to QA teams so that they're all performing testing in a dedicated, similar environment. And it's great for helping to make sure that we have fewer and fewer bugs as we're testing and moving our applications through the processes there. So yeah, like I said, kind of a tiny Terraform because it's designed to build a single box at a time, but it follows a lot of that same paradigm as Terraform, where you're defining everything as code within your Vagrant file, and then you're simply kicking that off with a Vagrant up command and building it out. I did try to include all of the links as well. So if you look in the bottom right-hand corner as I'm going through these slides, if you've got any more questions about any of these tools, it's great to hit up the official websites, which of course we maintain. Also easy to find with a quick search of, say, Hashicorp Vagrant or Hashicorp Terraform or anything like that. Next up is Hashicorp Packer. And Packer is all about machine image automation. So this tool is really special. It's an older tool within the projects that Hashicorp maintains, but it's one that continues to become more and more relevant over time. It's actually a key part of our strategy for enabling companies to be able to deliver truly immutable infrastructure, meaning that we build out a machine image with Packer, all of that driven by code, adjustable by external systems, adjustable by pipelines, by developers, et cetera, and be able to deploy that individual machine image out many, many times using a provisioning tool like Terraform. So instead of going through and doing change management and incident management type processes, whenever we encounter issues or whenever we're going to be deploying and releasing a new version of an application, we could potentially bake that into a Packer machine image and be able to deploy it at scale with Terraform. So it talks about some of the platforms over on the left-hand side here that Packer is compatible with. Of course, all of the major public cloud providers are out there, Amazon, Azure, and Google. Many other options for local installs as well, such as VMware or VirtualBox, DigitalOcean, Docker. There's many, many, many different solutions that are supported for image building with Packer. Definitely worth checking out if you've got some image building that you need to do, or if you're inching closer and closer to the immutable infrastructure world. All right, next up is Vault. And I won't spend too much time here because this is going to be a big focus of Nico's part of today's presentation, but about security automation. So we say that it provides the foundation for cloud security using a trusted source of identity. And that's a key point that I like to bring up about how Hashicorp Vault functions. It really relies on one or more trusted sources of identity to authenticate what we call the client. And the client could be a human user like us. It could be a virtual machine. It could be an application, a piece of code, anything like that. But the client will leverage one or more of those authentication methods to prove who it is. And then it can interact with Vault for the purposes of retrieving secret material. Could be passwords. It could be API keys. It could be certificates. Many, many different secret engines that exist within Vault. So it's a fantastic way to provide access to those secrets, to people, to tools, to teams, and to systems. There's also some use cases kind of outside of secrets management, but more focused on encryption. Vault has some internal cryptographic operations, and it's a great way to offload that responsibility from existing applications and pass it over to Vault to actually perform an encrypt or decrypt operation and then store that ciphertext within an existing database that maybe doesn't support transparent encryption or something of that nature. Also some nice integrations that exist out there in what we call advanced data protection. And this is essentially integration into large-scale enterprise type database and storage solutions. So you'll hear more about Vault because that's a big part of Nico's conversation here in a few minutes. All right, so let's talk next about Boundary. Boundary is really interesting. It is one of our newest projects. It's only been publicly announced for about 6 months now. And Boundary is all about simple and secure remote access. It lives within our secure product line. So a lot of the same folks that are in charge of HashiCorp Vault are in charge of HashiCorp Boundary in the product direction. And one of the things, if you're familiar with Vault at all, or if you look into that in the future, you'll see a lot of the patterns are mirrored here. Number one, in my diagram on the right-hand side, there's a step for authenticating with a trusted identity provider. So that same model holds true with Boundary. This is typically about human users that need secure access to a remote target. And first, our human user needs to prove who they are to make sure that they actually have access to it. Then we get to the authorized step at the bottom of the diagram, where we use codified policies within Boundary to dictate which targets, which machines, which hosts, whatever they may be, are actually available to that user. And then finally, we provide access to it. And by access, we mean a couple of different things here. So many of the companies that I've talked to that are interested in Boundary today, they're looking at ways to replace a large deployment of VPNs. They understand that there's some gaps out there when we want a human user to get access to a secure resource behind one of those private networks that they're not actually on. that bridging them onto that network with a VPN and potentially exposing them or giving them access to other resources than intended can be a problem. So it's one of the core use cases for Boundary. Another is the fact that the Boundary client that our human user here is actually interacting with, it's able to communicate directly with Hashicorp Vault for the purpose of retrieving secrets. So it's great because we never actually have to give the password, the API key, etc., to our human operator in this case. Instead, Boundary will establish the secure session, retrieve the credential from Vault and perform the login, and then effectively proxy the communication back and forth between the two. So it's a really cool project. Again, it's about 6 months old. I think we're on version 0.2 of Boundary right now, but it's received a lot of positive feedback from the community, and I definitely encourage you to look at it if that's something that you're interested in. Okay, next up is Consul. So this will also feature a little bit into Nico's presentation, but Consul is all about network automation. We like to say that Consul provides the foundation for cloud networking and automation, and making it really a core central service and registry for storing information, accessing information across all of these different sites. Consul has a number of different features or use cases within it, probably the most simple being as a service registry and a health monitoring service for all of the registered components of it. Next up is what we call network middleware automation. And this is where Consul can actually be used to dynamically update or dynamically reconfigure, sometimes in conjunction with Terraform as well, network services, network solutions that are out there from popular providers. The final example is what we call zero trust networking. So that's within a service mesh type context where we can, again, use identity-based controls to enforce security such that two individual service components are allowed to talk to each other, but maybe component number 3 is not. And all of that is driven by Consul being kind of a control plane over the Envoy proxy. Again, a little bit more about that when we get into Nico's presentation. All right, next project here is called Nomad, and Nomad is our flexible scheduler. It's always interesting when we start talking about Nomad because of some of the varied use cases that it actually has. First and foremost, Nomad is or can be a container orchestrator and useful for deploying, managing, and scaling containerized applications. There's some other popular projects out there that do that same kind of thing. So fortunately for us, Nomad has a number of other capabilities that it's able to bring to the table. So one of those happens to be legacy application orchestration. It effectively lets you take virtual machines and schedule them, jar files and schedule them, and other capabilities that exist outside of the space of containerized apps. And the final one area where Nomad has seen a lot of adoption, especially here lately, is in kind of batch style workflow orchestration. This is where we have some companies that are running large-scale machine learning projects where they need high-performance compute for a period of time, and Nomad is very well suited to be able to schedule that workload, execute it, and then remove that workload to maximize the value of that project. Okay, the final piece here that I'll talk about from the Hashicorp stack is Waypoint. And Waypoint is also another new member of the Hashicorp family, also publicly released about 6 months ago at the same time that Boundary was. Waypoint is a very exciting project. And the whole idea behind it is to be able to build, deploy, and release in a common fashion. So the tagline here says, hey, build, deploy, and release across all kinds of different platforms with a single configuration file and a single workflow. So that's a big deal. So it's a large project and a lot of work still has to go into it, but it's a very exciting first start. So again, the idea is to be able to build applications from any language or part of any framework, be able to deploy those across any platform, be it Kubernetes, be it AWS EC2 or whatever it may be, and finally be able to release the application into staged deployments and carefully monitor and determine and make sure that everything's gone correctly as part of that. So that's a little bit about Waypoint. All right, so to summarize all that up, I kind of go back to the very beginning, what we talked about for the cloud operating model. The whole idea behind all of HashiCorp's tools is to help you deliver application workloads into a multi-cloud environment using a single control plane for every one of those layers And the key 4 layers are called out here: runtime, networking, security, and infrastructure. Now, all of those different tools that I just mentioned, all 8 of those projects, are available to the community in an open source model right now. And then as teams get larger, or as we see the products get utilized at an enterprise scale, there are enterprise offerings from Hashicorp as well that include things like support, collaboration tools, policy and governance tools, things of that nature. And each one of those solutions is available in a kind of self-managed or self-hosted notion. And also one of the brand new services that we now offer, which we call HCP, and that's HashiCorp Cloud Platform. And that is a SaaS managed version of some of those tools. So no matter where you're at in that adoption journey of HashiCorp tooling, we should have some kind of a solution or a process to help you along. Okay, so with that, I've talked about all 8 of the initial tools and what we call the Hashi stack. Now I'd like to spend a few minutes going on a bit of a deeper dive into Terraform specifically, and then we'll talk about Terraform in the context of Kubernetes. So first up, another kind of primer on infrastructure as code. It's one of the core tenets to Terraform and the way that the entire application, the entire tool functions. So the idea behind infrastructure as code is that we codify, we write down the end state of our infrastructure, what we want it to look like, what systems, what components, what resources are going to be made up of it, and what the exact configuration is going to be. When we execute Terraform, Terraform will take the current state and make it match that desired state. We'll talk more about that keyword state here in just a few minutes as well. On the right-hand side of the screen here in this diagram, you can see a little bit about that workflow. We have operators that are interacting with Terraform, writing Terraform code, or consuming it from the public module registry, where there's literally thousands of examples that live out there already. They run through a typical Terraform workflow, a cycle of plan and apply, and they're interacting with a series of providers. More on providers in just a second, but they're effectively the plugins that teach Terraform how to talk to all these other systems out there. So it's kind of the core driving nature behind it. We couldn't talk about infrastructure as code without taking a quick peek at the code itself, or really the document itself. I always like to say that we do have a proprietary language here when it comes to Terraform and most HashiCorp products. It's called HCL, HashiCorp Configuration Language. I also don't want the word proprietary to scare anybody. It's designed to be easily readable by both us as human operators that might be trying to write it, or might be trying to read it and understand what someone else has written, but also still quick and efficient to execute from a machine standpoint. So this is just a simple example here where we've got a Google Compute instance that's been defined. We've got a DNS record that's been defined within that HCL type format. I mentioned providers just a minute ago. Now we're going to go into a little bit more detail about it. Providers are that plugin model that allows Terraform to function. Natively, the Terraform binary, the Terraform tool, doesn't know how to talk to any of these solutions. Instead, the provider plugin needs to be installed so that it can talk to AWS, or it can talk to Azure, or it can talk to a Kubernetes cluster directly. So the provider framework is very extensible, and we actually maintain a registry of these tools. So it's a great site to check out if you are familiar with Terraform already and want to see if existing providers or modules or things exist out there. This is a great source for you. If you happen to be new to this part of the ecosystem and you want to learn more, it's also a great place to go, because each one of these providers and each one of the modules has a considerable amount of documentation and examples underneath it. So it's a great learning tool as well for folks that are just starting on their Terraform journey. I mentioned a Terraform workflow earlier and the fact that there's multiple steps in it. And this is really important when we consider what that looks like. Terraform executes what we call runs. And for the purposes of this conversation, we'll say that there's 2 distinct types. The first is a Terraform plan. And this is where Terraform essentially executes a dry run. It looks at the configuration code that's been written, and it determines what changes need to be made to make reality match what we've written out in our infrastructure as code. The second step, the Terraform apply, is when we actually perform the execution of it. So this is when the provider is invoked and all of the APIs are called to reach out to that other system and actually perform those changes. And those changes could be creating brand new resources from scratch, like in the example you see on the screen. It could be making some changes to existing resources, or it could be removing existing resources when we're removing a particular set of resources now that the application is being decommissioned or something like that. So all those things are possible with Terraform because of this notion of state. State is very, very important from a Terraform context. It is a file that is kind of built and maintained by Terraform, and it dictates Terraform's understanding of the world, of the resources that were built. And the state file gets built and changed over time and iterated on, and it's also refreshed at every step of that workflow. So when we perform a Terraform plan, when we perform a Terraform apply, we're making sure that the state file is up to date so that we can actually have an accurate plan and, of course, an accurate apply when we actually move forward to make those changes. Okay, that's just a quick 10,000-foot view, if you will, of Terraform and some of the initial workflows there. Now I'll spend a few minutes talking about some Terraform and Kubernetes specific context and how the two can be used together. So first and foremost, we just talked about the provider system, and existing providers are out there for popular cloud providers, and many, if not all, of the services that they offer. So that includes Kubernetes services that are managed by the cloud providers themselves, like EKS, AKS, and GKE. That means that you can use, no matter which of those clouds that you're operating in, you can use the respective Terraform providers to provision these clusters, configure these clusters, and perform operations within them. Now, we understand that each cloud provider and many, many tools out there, they have native capabilities for provisioning and configuring these services. But Terraform does provide a couple of advantages that you may want to look into. The first of those is the concept of a unified workflow. So if you have yourself or other teams, other peers at your organization that are already deploying infrastructure with Terraform, then using, say, the EKS example, it could fit right into that exact same workflow. And there's an added benefit that you can deploy applications using Terraform once you've built the resources out there. Next up is the concept of full lifecycle management. As I mentioned earlier, Terraform isn't just provisioning resources. It's also got the ability to change existing and to delete existing. So there's great use cases there from a lifecycle standpoint. And then the final is the graph of relationships. So I mentioned that Terraform has a state file. Terraform also has a graph understanding of the dependencies and the relationships between the resources that you've built with Terraform. And what that means is that Terraform won't attempt to create something in the improper order. It won't attempt to remove something in the improper order. So it understands all of that. It doesn't require you to map out the exact order of operations when you're performing some of those steps. So it could be a nice alternative, especially in one of those scenarios where, like I said, yourself or other teams might be already using Terraform. So here's just a quick code example of what that looks like. Here we are calling on the AWS provider for Terraform. So effectively telling Terraform, hey, I need you to make sure you've got all the plugins to talk to AWS APIs. And then next up, an EKS module example sourced from the public module registry out there that shows some of the attributes that we need to populate to be able to interact with it. So fairly straightforward from an example standpoint. Now, there's several other ways to interact with Kubernetes, so I'll touch on each of those as well. The first is the actual Kubernetes provider itself. And this is an official provider, so it's built and maintained by Hashicorp, and it allows Terraform to manage Kubernetes resources. That includes a list that's defined based on the documentation link at the bottom down there. But this can be things like pods, services, policies, etc. Not every Kubernetes resource is supported. And so that's why we actually have the next slide on here, the Kubernetes Alpha provider, which made a lot of waves in the community when this was introduced, good waves of the good variety, because of the additional support that it offers in a Kubernetes context. So we're officially calling this an experimental provider. but it is regularly updated and maintained by Hashicorp, and it allows management of any and all Kubernetes resources, including custom resource definitions. So here's just a quick example of what that might look like, where we're actually treating, or we've actually built, if you will, a config map here within Terraform that can get passed over to Kubernetes. So just a short example, plenty more of those available at the link at the bottom. Next up is on the Helm side of things. So we actually maintain as well a Helm provider. This allows you to manage the charts that are installed in your cluster, really the same way that Helm does it, but doing it through Terraform. This is also an official provider, and you can see an example of what that code from a Terraform standpoint looks like right there. Okay, and I think this is last on my list. This kind of flips it around just a little bit. This is the Kubernetes operator for Terraform, and what this allows you to do is define and create infrastructure as code natively on the Kubernetes side, and then it simply makes calls out to either the Terraform cloud hosted application or an on-premise Terraform enterprise deployment as well. And there's an added benefit of this. So there's a great story that's actually told in the blog post that I've linked at the bottom down there. But one of the great examples is, hey, what if we need to create some other dependent resources that live outside of Kubernetes? It's a great benefit of this operator here because we can actually invoke that from the Kubernetes side to invoke Terraform to perform a run to create some of the downstream resources that need to be built outside of K8s. So I think that's it. Yep, that's the last example that I've got there. So I'll bring it over here to the Vault slide, kind of go out of presentation mode for a minute, and we'll start to transition over to Nico.
Thank you, Josh. Let me see if I can share my screen, given that I'll probably do a demo at some point if we have time. So screen one, let me know when you guys see my screen. Can you see my screen?
Not yet, Nico. I think it took a moment for mine to come up as well. Still no.
No, still no?
Still no. Anybody else? Is it just me or?
No, it's not visible. Nico, maybe you can try to use Google Chrome. Chromium.
That's what I'm using right now. Let me see. I'm pressing on. Let's see, Chrome tab. So I'm gonna do the Chrome tab right now, but I'm not sure if.
Do you see share your screen button?
Yeah, I can. I can click the screen. I'm clicking share, but it's not sharing. Let me try doing the window Chrome tab. Okay, can you see now?
Yes.
Okay, so I'll continue right now, but I'm not sure if I'll be able to share my demo. But let's take it one step at a time. All right, can you see the full screen now?
Yes, we can.
Okay, awesome. So thanks, Josh. So Josh can explain the COM model, the cloud operating model initially, and talked about the interaction between Terraform and Kubernetes. So now we'll dig into Vault in Kubernetes. So if you're not familiar with Vault, I'll have a quick overview, but over the next 10-15 minutes, I'll dig deeper into some of the key integrations between Vault as a secret engine with Kubernetes and why you should care. We'll talk about the Sidecar injector, the secret CSI driver, the Kubernetes auth method, and Vault running on top of Kubernetes with Helm. Those are the four key, I would say, integration points that we're seeing the Kubernetes community use or integrate with Vault. So at the high level, Vault itself is an open source secret management solution. We do have an enterprise version, as Josh mentioned earlier. It tightly controls access to secrets and encryption keys It's pluggable, and you have basically an authentication pluggability. So there's a different sets of authentication plugins, and there's a different set of secret engine plugins, and basically Vault's become this broker of a solution to enable you to consume and store secrets across different environments, and have this centralized way to, as I said, securely store your secrets and create dynamic secrets and encryption keys and so forth. So this is kind of the main goal, or the main benefit of using Vault. And we've seen some use cases where there's some interaction between, or there's a need for interacting or integrating with Kubernetes, specifically when it comes to secrets. So as you may be aware, Kubernetes has a built-in secret solution, Kubernetes Secrets. It is very straightforward to create secrets, which are first-class objects within Kubernetes. However, there's some limitations around just the native capability within Kubernetes. They're more specific to Kubernetes. They're not encrypted by default, and they're limited to Kubernetes itself. So Vault is a solution that addresses the need for consuming and storing secrets across the board for workloads running within Kubernetes and workloads running outside of Kubernetes on VMs, or like serverless applications, or across the board on any cloud, basically. So the first kind of approach, or the first kind of area that we want to address here, is for those applications and those pods within Kubernetes that are not aware of Vault. So if you are onboarding an application, or you have an application that you containerize and you're putting in Kubernetes, and you want to, this application expects either reading from an environment variable or a specific file system, it does not need to be aware of Vault, or the fact that Vault is involved in the process of securely retrieving the secret itself. And for this approach, we have two solutions. One is called the Sidecar pattern, or the Sidecar injection, basically, approach. And the other one is a relatively new solution called CSI, Secret Store. So we'll dissect each of those individually. So the first one being Sidecar pattern. So there's a couple of solutions out there. I believe Envoy is one of them, and other solutions where there's pattern within Kubernetes to inject, based on annotations when you create the pod, to inject a secondary container within that pod on demand, basically, for it to either manipulate the file system, or in Vault's case, interact directly with Vault server or the Vault cluster, and on behalf of the pod's identity, authenticate and retrieve any required secrets, and then render them for the application itself, without the application pod being even aware of this whole thing happening. So this is kind of the key value of using this Sidecar Vault. So Vault will be created, a Vault agent will be created as a container, alongside the containers that are making the application pod. This is done automatically, and the injection is done seamlessly. So the application themselves don't, they only need to be concerned about themselves and finding the secrets. They don't have to care about interacting with Vault and retrieving the secrets and authenticating and so forth. In order to do this, there's 4 key requirements, right? Kubernetes auth methods. So this is on the Vault side. There's auth methods, or auth engines, plugins. You can call them that way. There's Kubernetes is one of the auth engines that is required to be configured. We'll talk more about this, but basically this allows for this integration between Vault and Kubernetes to actually happen seamlessly behind the scene. The pod, second, the pod has to have a service account, which is the default setting. You can use the default service account, or you can create a separate service account. The desired secret for the application needs to be pre-created within Vault, and this is kind of good, thing to point out. So if imagine if you have some pods that are using the same secret as like a VM that uses the same secret that's outside of Kubernetes. If you're using the existing just purely Kubernetes secrets, you have to create them in 2 different places, like Vault and within the Kubernetes secret as a Kubernetes secrets, but in this case, you only have to create them once in Vault, and they're consumed by that VM and by that pod. And finally, the fourth requirement is the service account should be bound to a Vault role. So this is the authorization piece to make sure that this specific pod and that is identified with its service account has access to that specific and has like the right set of privileges to access the desired secret. So we make this whole, I know that sounded a bit complex, but we make it extremely easy to deploy both Vault itself, but even the Sidecar pods with just Helm. So there's a Helm charge that we release, so you can just use Helm to create this Sidecar injector pod, and as long as you have the right annotation when you create your application pods, automatically those Vault will be created alongside the pod itself. So how does this work behind the scene? So if you look at the left-hand side, you have your Kubernetes application pod, and that's running, and the kubelet is running on every node. You can see here that as soon as you create the application pod itself, there's a Sidecar container that is created. So by default, and actually this is outside of the Vault integration, every pod inherits a service account, which is assigned JOT token that kubelet provides to it, and it is available for the pod itself in its file system. This Sidecar container uses that as an identity for the pod itself, and it automatically authenticates to Vault server or Vault cluster, depending on how you're deploying Vault itself, using that JOT token. This assumes that within Vault, you have configured your integration with Kubernetes itself, the Kubernetes API, and Vault on the applications or on the pod's behalf would ask Kubernetes API, hey, I have this JOT token. Is this this pod? Is this a real pod? It confirms the identity of the pod, and based on the policy that's attached to this identity, if Kubernetes confirms the identity of the pod, there's a policy that checks within Vault what types of secrets and what role does it have, and based on that would provide back a token that then can be used to retrieve basically the required secrets that this application needs. So all this stuff happens behind the scene with this approach. So all you have to do really, from assuming that you have deployed your the different component I talked about, Vault, Vault is running, the integration with Kubernetes API is configured. Really all you have to do is add a couple, and the Sidecar Helm chart is deployed, which is just a container that is using the Kubernetes mutation webhook API that watches for different pod events. So all you have to do from an application perspective is add a couple of annotations. So let's talk about those annotations real quick. One is just to enable this auto injection. So the default, I believe, is false. So you enable it by changing that to true. You add the role that is mapped to the role within Vault for this specific pod. So this would require some ensuring that you have that pre-created within Vault. And of course, you have to include the key that maps to the key that's mapped to the secret name within Vault, and the value. The value is mapped to the secret name within Vault, and the key will eventually map to the name within the pod's file system within your application. And if that works, and we'll see it hopefully work if I can share my screen, you can see that assuming here that we're execing into a pod that's called payroll, we're catting, there's a default setting for Vault secrets, and then that's the database config. We can see that it is rendered within the pod itself as a in-memory file, shared file system that is the secret itself. So this is what the application sees at the end of the day, but it did not have to authenticate, did not have to do any work itself to retrieve this secret. Now, this brings us to the other option that we have, and this is relatively, I think the secret injection kind of pattern GA'd in 2019, but I think it's been widely used even prior to that, between 2017 and 2018. So it is probably the most common approach that I've seen a lot of our users use today. Now, there's another approach that uses CSI. So CSI itself, I don't know how many of you have heard that term. It is a container storage interface. It is standard for exposing arbitrary block or file systems to containerized workloads within Kubernetes. And actually, beyond Kubernetes, Nomad is another solution that we have that also utilizes the CSI interface itself. CSI uses third-party storage providers and also cloud storage providers plugins to expose the storage systems to Kubernetes without ever having to touch the core Kubernetes code. So it's kind of outside of out of tree, so it does not live within the Kubernetes code base itself. So the secret store CSI is a type of CSIs that is more focused on using the CSI model to provide or render basically secrets as a file system to the pod itself. It's not going to be in memory, but this time it's going to be actually as a file system, similar to how you use CSI for block storage or file system storage for the pods themselves. So one of the implementation of this CSIs or the secret source CSIs is Vault. So we are, Hashicorp maintains that, and you can specify it in terms of how you define your CSI, so you can configure that. So this is the name of the driver. It's a secret store CSI. So allows kind of Kubernetes, as I said, to mount multiple secrets, keys, certs, whatever you want, anything that is of as a secret in nature in an enterprise grade external secret store to implement that or integrate that or expose that within the Kubernetes pods themselves. So as I said, one example that the Vault provider is one of the secret source CSI providers, and we maintain and manage that, and it's of course open source. So there's a couple of requirements to get to use CSI, and we'll talk more about when do you want to use CSI versus when do you want to use a sidecar injection. So you need to install the secret store CSI driver, install the provider Vault executable, define the secret provider class, Kubernetes resource, and then define within the pod, define the volume itself, and defining the secret that you want to use or expose within the pod. So I think it's slightly more complex to configure, but there's definitely some advantages that we'll talk about in a bit. So I don't want to. I think we have a very clean kind of tutorial that walks through the different use case. The different steps here, but we have a Helm chart. There is an existing Helm chart for deploying the secret store CSI driver, and then you install it with just a Helm install command, and then you provide the Vault specific executable as a daemon set that runs on every single node within your cluster, and then you create the secret provider class that you're defining how you're basically configuring this class and how it speaks to the Vault server or cluster that you have, and the credentials and all that stuff. And then finally, you provide, this is how you configure the class itself. You provide the Vault address, TLS config, the role name that allows it to actually retrieve secrets and talk to and authenticate against Vault itself. And then the final step here is within the pod itself, how you want to mount that secret, in which directory. One thing I want to note that unlike both Kubernetes secrets and Sidecar injected secrets, which both use in-memory shared volumes. CSI uses host paths, so it's an actual file system that is not in memory. So that's a key difference between the two. And as I said here, there's just additional metadata configuration within your pod spec to align or configure how you want to mount the secret within your pod. This is just exactly what I just said. And then you can see that if you want to view the secret, you can see it within the configured path that you specified in the pod spec, and you can see that the secret that you actually was automatically retrieved on the pod's behalf by the CSI driver. So in both cases, just to kind of make sure that in both cases, the pod itself, the application pod, is not aware of Vault. It does not interact with Vault directly. And there's no specific configuration between the pod or the application against Vault itself. Some of the configuration that I showed here are actually across the secret store class. So this is a one-time thing that you need to define. But then either the CSI or the Sidecar injector, they both interact on behalf of the application with Vault. And there's a really neat tutorial that we have on our Learn platform that you can go through, that goes through just an end-to-end deployment for both the Sidecar pattern as well as the CSI volume. So you can feel free to go through that tutorial if you want to learn more and have some kind of hands-on experience. So I wanted to kind of compare between the two, given that the CSI is relatively new. It just went graduate to beta from alpha recently with, I think, Vault 1.7. Both approaches are supported by Hashicorp, but as I said, the Sidecar approach is probably a lot more widely adopted since GA back in 2019. Sidecar approach is deployed as a container within every application pod. So that means that it will eventually require more resources, more CPU, more memory, because you have an additional container per pod, while CSI itself is deployed as a daemon set. So that's going to be deployed once per node within your Kubernetes cluster. Regardless of the number of pods that are consuming the CSI, it's just going to be depending on that daemon set to interact with Vault itself. Sidecar does not support environment variables. CSI does. So if you want to expose, although there are ways you can render things as an environment variable, but if your application, there's a more native way within using the CSI model to render your secrets as environment variables. Sidecar does support templating secret values. CSI does not. So if you wanna, we'll show an example of that if I have time. You can template. So if you want to retrieve a secret and then there's a specific format that the application itself is expecting, whether it is a connection string for Postgres or a database that you want to just template and just render and inject the secret into it, that is something that is supported with the Sidecar. It's not with CSI. Sidecar does support OpenShift. I think there's some. I'm not too familiar with some of the issues right now with CSI and OpenShift. But according to our engineering, it is not supported with OpenShift. CSI is not. Sidecar writes secrets to a memory volume. I think I spoke to this. CSI store does not. It writes to a host path volume, and I've seen there's some environments where that even the ability to write to host path is something that is is prevented or not allowed within certain environments. So if that is the case, then the CSI option is probably not going to be a good option for you. I think that's it. Sidecar doesn't really have any Kubernetes requirements, something that's been supported, with any Kubernetes one, any Kubernetes basically. And then CSI requires newer APIs. I think introduced some of the CSI itself when GA in 1.13. So I wanted to kind of highlight some of the key differences between the two approaches. Again, both of them, you don't have to change anything in the application for you to be able to consume those secrets. So now, if Vault itself exposes an API, and lots of the workflows that we've seen today are API driven. So there's a lot of libraries that if you want to write some of the logic within your application to interact directly with Vault, there's a lot of examples to do that. There's many examples online also you can read on, but it's the most native way to interact with Vault is directly by talking directly to Vault. You have a lot more. You can basically take advantage of a lot more functionalities within Vault if you can directly talk with the API, as opposed to waiting on kind of proxy to do that on your behalf, like the Sidecar or the CSI in this case. So in order to do that, and if you're writing net new applications or the application is already aware of the Vault API and can authenticate against it, then great. Then you can just use this method, which is the Kubernetes authentication for Vault. So the really the advantage really here is that, remember when I talked about this the service account for the pods and how we can use that to authenticate against Vault. So this is what is called a secret zero problem. So that's kind of your first initial identity to be able to talk to Vault itself. And that's a solved problem. If you're running within Kubernetes, then you can just use the Kubernetes auth method. That way you can use the existing pods will come up with their own they'll come up with their own service accounts. So you don't have to do any extra work. You just use the service account. You have access to it within the pod. You can use that account that JWT token to authenticate against Vault. Vault with this Kubernetes auth integration, you enable it on Vault. You integrate it with Kubernetes cluster, and that will enable it to identify you as a pod when you pass it the JWT token, and therefore at that point you don't have to deal with additional identity. That would become your identity zero basically within this workflow, and then you can receive the token, a short-lived token or long-lived token depending on your configuration, and continue working with Vault after that. So we talked about those three integrations to CSI and Sidecar injectors for Vault unaware workflows. We talked about using the authentication, the Kubernetes authentication, if for Vault aware workflows. And finally, the last thing I want to kind of mention for Vault itself, as well as Vault Enterprise, we have produced Helm charts that are supported for open source and enterprise to be able to deploy single server or highly available deployments of Vault itself onto Kubernetes that are fully supported. So that's kind of if you're running Vault, today, or you want to run it on Kubernetes, that's another integration point that you want to be aware of. So it makes it extremely easy to get going and deploy it in a supported fashion on top of Kubernetes. I am done with the slides. I know that we're on top of the hour. I don't know if we have time. If we don't, then I'm okay not doing a demo. But I had a sharing issues, so sharing my screen issue before so I'm not sure if I will be able to, but I can give it a try. And if there's any questions in the meantime, I can answer. Let's go ahead.
We have all the time you need. Thank you.
Okay, perfect. Let me give it another try. Okay. Let's see. Sharing the screen is not Chrome tab. It's not the Chrome tab. Could it be that I had, it had it blocked? 1 second, please.
You might have to do a quick refresh and rejoin the website.
Yeah, I'm trying to look at the maybe USB. I'm looking at the
Yeah,
I am looking at the permission. Yeah.
Go ahead.
So yeah, I'm looking at the permissions within Chrome to allow this. I'm trying to see which permission.
Yeah, I was noticing that I was getting the same kind of issues. I've had it a couple times. If try just like doing a shift, refresh or just a hard refresh.
Okay.
For me.
Okay.
Yeah, try that.
Okay. Let me try to reload. Oh, okay. So
Awesome.
let me reload.
Cool. Better or worse?
Let's try again. I think I tried to refresh. I think there is probably a missing.
Nevertheless, while you're trying to kind of figure that out, and I'll give you just a couple seconds to kind of dig around for a minute. But I just want to say that was a great presentation. I'm absolutely, hi, by the way, everyone. My name is Brian. I'm another co-host of Mars. And I just want to say I absolutely love all the things that Hashicorp does. So thank you for that. Especially just talking about Vault and how important it is and just generally in the ecosystem. So it's really cool to see the progress that the CSI driver is really bringing to the table through the daemon sets. So I know I've just seen a lot of people kind of shift away from the general sidecar deployment just because we know it's a little bit more difficult to kind of upgrade and manage. So it's really, really cool to see the new CSI adoption. So I just wanted to kind of throw that at you. If you are running into troubles with your demo, we completely understand. Things happen, so I totally understand if you can't bring it up, and don't feel any pressure.
Yeah, I'm gonna give it one more try because I enabled all the permissions within Chrome.
No, I completely know.
Still not seeing the.
Okay, no worries.
If I allow the window, let me actually see the window. This one. Yeah, it's anything related to, maybe this is a Mac thing. I think this is a Mac thing because it's allowing me to share anything within Chrome. So if you give me a minute, but I'm not seeing any pop-up for allowing my screen to be shared. So if you have any guidance on that.
Yeah, let me see. I'm gonna try one setting. I'm gonna try to do something through this platform because I know Bevy sometimes gives us a little trouble. But one second, I'm gonna try something. So I'm gonna take you off, and then I'm gonna put you back on as presenter. Let's see. Did you get any more additional privileges? I just disabled it and re-enabled it for you. And what's interesting is that I can actually host. I can actually share my screen just fine, which is really odd. But yeah, I think you're right. I'm using the Mac as well, and there's definitely those extra privileges and the things that you have to tweak a little bit in your preferences. But hey, nevertheless, that's completely okay. I don't want to put any too much pressure, and we completely understand. I was just going to ask, from the future and what your opinion is, Nico. What do you think? I don't know. What are you most excited about? Just in general about what Hash is doing in your space. You have Vault, you have Nomad, you have Waypoint. I mean, you have all these fantastic things. I'm just curious. And by the way, Nico, just so you know, you are still muted.
Yeah, I'm still muted. So here we go. And Josh, feel free to chime in because Josh is also my peer, and we might be excited about the same thing. That would be good. Yeah, I think there's a lot of, as you said, especially around Kubernetes, the stuff that we've been working on with the CSI, just giving an option for developers and users to consume and seamlessly consume secrets. I think it's extremely I think it's beautiful right now. I want to use the word beautiful because it's, for someone who doesn't have to deal with all the intricacies of kind of authenticating with Vault and just seeing the secrets there. And we're talking about like a more secure way to actually get the secret. They're encrypted within Vault. They're encrypted on the way to the pods. They're removed completely. If the pod is gone. Actually, part of my demo was around using dynamic secrets, and especially on the Sidecar piece, what I wanted to demo was around if you have dynamic secrets with a TTL, for example. If you have you're generating Postgres secrets with that are short-lived, by just defining the policy within Vault to say, hey, this secret is only valid for 2 minutes, and when the new secret before this new secret is actually created, automatically the Vault sidecar would fetch a new secret and inject it into the pod without the application even worrying about that. So I think although it seems very seamless from 10,000 foot view, it's actually a lot of things are happening in the background to make it secure by default, and basically use all the really cool features within Vault that make secret management, key management, cert management really easy and really secure. So that is actually pretty exciting, and continuing the CSI approach is also pretty exciting because that gives another option for Kubernetes users. I don't know if Josh has other thoughts, especially on the.
Yeah, I do, Nico. Thanks for that. So, I mean, my thought, I'll go a little bit more broad with my explanation. So the thing that has me most excited from Hashicorp is related to the cloud platform, HCP, Hashicorp Cloud Platform. And that's the ability for individual developers all the way up to large-scale enterprises to consume our software as a service without having to install it, host it, manage it, update it, patch it, etc. We all know that there are steps that are involved in that. We know that there are considerations that have to be made and resource costs for running and hosting all these things. And that HCP motion takes that entire burden off of you as an individual, right, or as a company. So it's definitely the thing that's most exciting for me, because people can, and anybody on this call, in fact, we have a free developer tier. You get, I think, 30 days worth of credits for free. So you can try out HCP Vault or HCP Consul. It runs in AWS today. More cloud providers will be added in the future as those services continue to be developed. But with a couple of mouse clicks and no payment information, by the way, you get a fully functioning Vault cluster or a fully functioning Consul cluster that you can use for learning, for testing, for use case evaluation, and things of that nature. So it's super exciting to me that we can now more quickly and more easily get the tools in the hands of individuals and small teams like that.
1 second, my dog is just barking. I don't want it to bark. Yeah, see that? I don't want you. My apologies. I just did that one. Anyway.
Oh yeah, that's okay.
So I'll be quick. Yeah, honestly, I love one thing I really love about HashiCorp. First off, Josh, that's an excellent point, right? We know how hard this infrastructure is and how to build this stuff, but it getting to the point, just getting to the users and developers and the tools that they need to actually build and reduce agility or to increase agility is extremely important, and I do love that product as well. Yeah, and I just wanted to say, we don't have to go much longer, but first off, again, Hashi, I absolutely adore everything that you build. I think you're so great and the cool things that you're always doing. And I just want to thank you so much, honestly, just coming to the Dallas Kubernetes Meetup and sharing all this with us. Yeah, you guys are great. So thank you so much.
Brian, it's our pleasure.
Yes.
Thank you very much, Josh. Thank you very much, Nico and Brian, for chiming in. Thank you.
Absolutely. Hopefully soon we'll actually meet in a real room together. So yeah. All right.
Yes.
Thanks, everyone.
Thank you. Have a great Memorial Day weekend.
Thank you.
Thanks. Bye.
Bye.